Good morning, Structures of Math students. This is Mr. Marquetta, and today we're going to study chapters 3.1 and 3.2, which are associated with word problems that have to do with subtraction and addition. In our last video, we discussed Roman numerals and scientific notation. In this video, we're going to finish Unit 2 by exploring chapters 3.1 and 3.2. I had asked for you before you came to class or somewhere along the line to make it through these exercises. If you would like to see an explanation for these exercises, please look at our previous video. They're all explained in detail how to come up with the answers for these, but you should be fluent enough in Roman numerals to be able to look at these examples and come back with the Hindu Arabic numbers, which are the numbers from our number system like 1971 and so on. So let's begin with some basic definitions. Most of you already know a lot of these words, but there are a couple words that you may never have heard of, so we have to kind of throw them in there, and you will see vocabulary questions on your next exam. There's words here that we should be able to throw around on a regular basis when we're talking with our colleagues in the elementary school. And when you hear words like this, you should know right then and there what they are. Addition. Numbers are added together and they are called addends, and that creates a sum. So in the case of A plus B equals C, A and B are the addends, and C is the sum. Okay, I think we knew about the sum. You may not have heard about addends before, but that's what those are called. Next, subtraction. A difference. The difference is the result of one number, which is called the minuend, decreased by the second number, which is called the subtrahend. So in the scenario D minus E equals F, we can say F is the difference, the minuend is D, and the subtrahend is E, okay? So it's the minuend minus the subtrahend. Think of it as if the subtrahend is the thing being subtracted out. That's the subtrahend, right? And then we have terms. Terms are the numbers that are the sum, difference, addends, minuends, subtrahends. Those are called terms. In this unit, Unit 2, we're only going to explore addition and subtraction word problems. There are more terms associated with multiplication and division problems, and when we do that part of our instruction, we'll work on that piece, and we'll use those terms at that time. Okay, so we have some words here we have to know. Addition, sum, addends, subtraction, difference, minuend, subtrahend, and terms, which is what we call all of them. Okay, so in order to be able to really have a solid grasp on addition and subtraction, is you have to accept it that they are the same thing. And it's hard to see that unless you've done a lot of algebra in your life, or after you teach this for a couple of years, it'll dawn on you and you'll finally see and realize that addition and subtraction really are the same thing. Some of you already can dig it, but the point is that when you see a subtraction, it's just an alternative of what addition could be. It's the same thing, it's the same idea as addition, but it's just kind of in a different order. And because of that, we want to think of both of them as if they are the same thing. If we think of both addition and subtraction as if they're the same thing, then a lot of our teaching is easier than you know, and all kinds of things that you're planning fall together very easy and a lot easier than if you treat them like they're two separate units and two separate things. You don't necessarily need to preach to the kids that addition and subtraction are the same thing. That's not important. In fact, it might be detrimental to try to tell them that they are the same thing. But as adults and as teachers, we need to understand and believe that addition and subtraction are very, very closely related. They're basically the same thing. So every statement about subtraction corresponds to another statement about addition. And as you see here, if we wanted to say A minus B equals C, it is the same statement as C plus B must equal A. In other words, there are two pieces and put them together and you get the other piece. Or we have a piece and we take one piece out and we get the other piece. It's three pieces. So you could show these three pieces, of course, using your best friend, the strip diagram. And here's a strip diagram. This one is horizontal. Sometimes strip diagrams are vertical, like we had before when we were studying other topics. It depends on what you're showing and what you're trying to explain. You may feel like when you're explaining how to relate addition and subtraction, you want to use a vertical one. That's okay. But when it comes to strip diagrams, remember what they are. A strip diagram is a kind of heuristic that employs a very basic, long, skinny rectangle that you can cut into parts to represent quantities as part of a whole. That's what a strip diagram is. And In this strip diagram, you can see we have two regions. We have the B region and we have the C region. And put them together and you get the A region. This is the strip diagram associated with the first two statements we just looked at back here. So these can be explained for the visual student using a diagram like this, okay? This is a great example of a strong use of a strip diagram to help students understand a complicated topic. Okay, so now that we've began and we've talked a little bit about the ideas of addition and subtraction, and we've kind of related them and we understand how they kind of mean the same thing, we can see what they look like using variables like A, B, and C. We can see what they look like using visual aids like the strip diagram, and we have a solid grasp now as teachers on how to think about addition and subtraction, two parts that make one more part. Now we're going to examine the kinds of word problems that exist for the kids in the lower grades associated with addition and subtraction. So let me try to be clear about this and make this really, I want to make it as clear as I can for you. When you begin teaching in a public school, and it's time for you to prepare your students and to get them ready for an exam or for a standardized test or for the grade-specific level tests and the things that you need them to succeed on. When you're creating assessments and when you're creating materials and creating different kinds of practice for them, I say to you, write some word problems about addition and subtraction, off the top of your head, you probably could think up a couple of them, right? Johnny has 10 apples and Paulie has 3 apples. How many do they have together? Things like that, right? Well, those kinds of word problems are really in 4 different styles. And as an elementary school teacher, you have to have the wherewithal to be able to look at them and recognize which are the same group of a style of questions and which really belong to this group. There are 4 groups of kinds of questions when it comes to addition and subtraction scenarios. We're going to discuss them today. So why are we learning this? We're learning this because we want to be great teachers and we want to understand our subject matter really well, to the point that we can even analyze and take apart the structure and see what actually are the components of the structure. When you're teaching word problems and comprehension and reasoning to your students about addition and subtraction, they must be exposed to all 4 of these kinds of problems if you want them to leave the 3rd grade really knowing the word problems. And it's important that when you make a test, that you are careful to include a couple add to problems, a couple take from problems, a couple put together, take apart. Like, in other words, you have to use that kind of a structure and try to make it a well-rounded kind of lesson. And this is the key to how to make word problems a well-rounded, appropriate lesson, okay? So let's go through them one at a time. They're easy to confuse, so I'm going to show you the parts where you can look for little details to know how to classify a word problem as one of these 4. And when we are finished with today's lesson, I have a really great activity for you guys to do, and that we'll be working on between now and the exam. And we'll be working on it in class on next week's lesson before the exam. And it's a document that was made by previous students who created word problems. And then we all had a conversation and determined what style each one was. And then I took them all and scrambled them and put them on a worksheet so you can go and use them as examples to explore and try to classify. I want you guys to leave structures of math being really good at this part. This is one of the most important lessons, that when you go and have an interview with a principal to try to get a job and they ask you things like, what kind of things are you interested in math? Word problems are the answer. Knowing different structures with word problems are the answer. I'm trying to help you guys with career a little bit here. This is the kind of thing that people don't want to learn about, that people don't want to do, that they need people like you to do, and that it will be the thing that brings you in. So let's focus together on this. It's really not that challenging. I'm going to help you understand how they work. And you'll see as we go through them, they're not as confusing as they seem. Just at a first glance, it's a little tricky to figure out which one is which, okay? So what are the kinds of word problems we have? Well, let's see. We have 4 kinds, okay? We have add to, take from, put together and take apart, and we have compare. Let's see what each of these looks like, and let's explore them and try to get a good grasp on how to determine which is which. First, we're going to talk about the add to and take from problems. Under the umbrella of add to and take from, which is the first 2 kinds, we have 3 styles underneath that of each kind as well. We have the result unknown, we have the change unknown, and we have the start unknown, okay? So we're talking about an add to problem or a take from problem. A problem like that involves a change over time. For example, Anthony has 10 pencils. Tomorrow, Anthony found 3 pencils. So now, how many does Anthony have? Time has passed, and the reason why we have add to or take from is because originally there wasn't an amount, that was our start amount. Then there was a change amount, and now there is a result amount, okay? So here are some great examples of how to recognize add to problems and how to identify which subtype it is. Remember that we're talking about the result, the change, and the start. If this is about addition, I want to start this idea by sharing the basic structure of the addition problem so that we're familiar with how to kind of connect them, okay? When it comes to addition, and I'm going to start right here. When it comes to addition, we have this plus this equals this, right? This is our general addition structure, okay? This is the start. This is the change. This is the result, okay? This is the basic addition structure. The reason why I'm sharing this with you now, my friends, is because think about a question where the start is unknown. Anthony started with a certain amount of pencils, and then he got 3 pencils, so now he has 13 pencils. That's what it would be, start unknown. See the idea? Anthony had 10 pencils, then he got some pencils. Now he has 13. That means the change was unknown. How about Anthony has 10 pencils, and then he got 3, so now how many does he have? Now the result's unknown. See what we mean by start unknown, change unknown, result unknown. These are called subtypes, that this is unknown is one subtype, that this is the unknown is the next, and that this is unknown is the next. For addition and subtraction and multiplication and division, there's a beginning, a change, and an end. And in that story, there's different ways to tell that story. The first way we're talking about is add to, which means time has gone by, okay? So let's keep this structure up and let's carry on with our lesson. So here's a great example of a result unknown. We don't know what the result is. We're asking the child to find the result. Rachel has 23 CDs, and then she got 18 more CDs. How many does she have now? So the structure is 23 plus 18 equals blank, right? And the strip diagram associated with this looks like this here, meaning that I'm showing the two parts, 23 and 18 being put together, and the unknown is signified by a little box up above to show this is what I'm looking for. So this is what we mean by the result unknown. Now let's look at the change unknown. Rachel had 23 CDs. After she got some more, she had 41 CDs. So now how many CDs did Rachel get? Well, you could say it's 23 plus blank equals 41. However, also, some students will look at this and think, oh no, it's 41 minus 23 equals blank. And as you could see, both of them are the same structure. And that's what we mean, my friends, by thinking about addition and subtraction being the same, especially to the first and second grade child, that they are one and the same, because they see it in a different way than they do. They see it with new eyes. We've seen subtraction 1,000,000 times in 1,000,000 scenarios with algebra and with geometry and with statistics and with money and with 1,000,000 different ways. And the kids have only seen numbers in class with you. So when you start giving them a story about someone who has CDs and got some more and wound up with an amount, they think of it as both addition and subtraction. Some kids will think that's a subtraction. Some kids will think that's an addition. And the best part is all of them are thinking correctly. It's really both, right? Okay, so because of that, if we wanted to show a structure, we would either do 23 plus blank equals 41, or we could say 41 minus 23 equals blank. And of course, we have a strip diagram to go along with this. We know one part is 23. We don't know what our other part is, and we do know the total part is 41. By the way, notice this strip diagram has this lovely little dotted curved line. Okay, you may not have seen that yet from the strip diagram. You could put lines or any kind of bracket or some kind of nice writing to, get creative. You're gonna have a marker and a whiteboard in front of you. Put something nice there to show that the whole thing does mean 41. And don't be afraid to mark up your strip diagrams. Strip diagrams are tools. They're not precious, perfect things that cannot be edited. You can write numbers in them, you can cross them out, you can highlight them, you can color them in different colors. You know, be a little bit flexible with messing around with your strip diagrams to really try to bring the message across and help your students learn. This stuff is not that hard if you try to really show different ways to show it. I mean, like for example, here you have geometry and you have equations at the same time. So there's a lot of opportunities for our kids to understand this area. Moving on to start unknown. So Rachel started with some amount of CDs we don't know in this case. Rachel had some CDs, but she got 18 more, now she has 41. So how many CDs did Rachel have before? And now you see two structures there. As you can see, one of them is an addition structure where one of the add-ins is missing. And then we also show it as a subtraction structure where the difference is missing. And you could show it in either way. Students will think of it in both of these ways. And then we have a strip diagram where we see that the first number, the blue number, is the empty one. And we can look at that strip diagram and come up with a conjecture that I think I better minus 41 and 18, right? And that's how the kids will think. This is called an add to problem because we start with a quantity, some time passes by, and then there is a new quantity. That's why these are called add to problems. Underneath the add to problems, we have three subtypes based on which part of the structure is unknown. That's the first kind of word problem we'll study. The second time is called a take from. Now here's what we mean by a take from problem. We have Rachel had 41 CDs and then she gave away 23. Now how many does she have now? In this case, what's happening is our basic structure is not an addition structure, it is instead a subtraction structure. So for a little extra clarification, what does the subtraction structure look like? All right, well, here's your basic subtraction structure. And we have the start minus the change equals the result. While we're in this conversation, why not remind our students of the vocabulary, of the minuend here, the subtrahend here, and here we have the difference. Okay, so again, with take away, it's very much like add to in that time has to pass. Take away is that at 1 minute, there's a certain quantity, and then some time passes and something is taken away, because it's called a take away problem. And then after something is taken away, now there is a result. So there's time going by. And the time going by in your imagination is significant and helps you to realize this style of question. The add to and take from both require the idea of time going by, okay? So we'll keep that structure there and we'll carry on with our examples. So Rachel had 41 CDs and she gave away 23. How many does she have now? Here's what the structure looks like. It's a subtraction case with a blank where the difference is. And what does it look like when it comes to a strip diagram? Not that different than the add to problems, right? Look at it, it's almost the same kind of thing. Okay, change unknown here. Okay, well the change was unknown and we took away. Rachel had 41 CDs and then she gave some away and now she has 18 left. So how many does she give away? Two structures here. You could think it's 41 minus some number will give 18. Some students will think a little bit more ahead and think, well, I could just do 41 minus 18 because I have an intuitive sense of the commutative property, you know, in addition, and that's pretty deep. And some students will be able to see that, well, if I pull out a number from 41 and I get 18, why don't I just take 41 minus 18? Not every student is going to see that. If you keep on drawing these strip diagrams, though, some of those students will start to see that. And that's one of the beautiful things about strip diagrams is there are lessons in them that you don't even know you're teaching when you're showing them, that certain students will get a little bit of a light bulb over their head randomly looking at what you're writing. And strip diagrams and other diagrams have that effect in a math class. And that's one of the greatest things about math is sometimes we're teaching and we don't even know what we're teaching and the kids are learning lessons we didn't even necessarily plan to teach them. Okay, start unknown. Rachel had some CDs and then she gave 23 away, so now she has 18 left. How many did she have before? So the structure could be some number I don't know is the beginning number, it's the starting number, and I took away 23 and I get 18. Some students will see that you could just go ahead and add 23 and 18 to get your solution. And if you drew a strip diagram, it's the start that you don't know, which is the number above, and then on the bottom we have both of these numbers. The add to and the take from problems, I reiterate, are about time going by. Now we're going to talk about the put together and take apart problem. Put together and take apart problems involve distinct parts that make a whole, but do not involve a change over time. Put together and take apart problems have three kinds: the total unknown, the add-in unknown, and the both add-ins unknown. So when it comes to put together and take apart, generally, we're going back again to our addition structure. And recall that in our addition structure, we have two add-ins. These are the add-ins. And then if you remember, this number is called the sum, right? Okay. So we have a start, and then we have a change and a result. That's what it looks like when you have a take away or add to problem. In the case of a put together take apart, you have part one, and you have part two, and then you have a whole. This is the basic addition structure. And you're going to use this structure for the put together take apart problems. Remember, these are add-ins, and this is the sum. So using this as our structure now, let's see if we can make sense of some of these questions that are put together and take apart questions. Here's a scenario where the total is unknown. Rachel has 23 hip hop CDs and 18 rap CDs, and no others. How many CDs does she have in all? Notice that Rachel didn't go and buy 23 hip hop CDs today and then go and buy 18 rap CDs tomorrow, right? Rachel already has them all in her hands right now. This is why this is called put together and take apart instead of add to and take from. Add to and take from, again, is about time. This is about a story about one person or one event all at once happening. So we could show that structure by writing a strip diagram and putting 23 and 18 in there and thinking about how we need to find the box that represents the sum of them or the total of them. The structure is given there, 23 plus 18 equals blank. And also there's something called a number bond that your book shows, which is very closely associated with a strip diagram. You don't need to know about the number bond for our class, but someday you'll be teaching in a public school and it'll be 2033 and they'll be suddenly using number bonds, and you might remember our conversation today. It's another heuristic or tool to help students with take apart and put together problems. Don't concern yourself too much with it. We need to be familiar very much so with the strip diagrams and with the structures, okay? What happens when one of the add-ins is unknown? When one of the add-ins is unknown, it looks like this. Rachel has 41 CDs, and if 23 are hip hop and the rest are rap, well, then how many rap CDs does she have? Well, now what's happening is you know the total, 41, and you also know one of the two quantities, 23. You're looking for one of the quantities for the other add-in, and only one of these add-ins is known, 23, the other one is not. You can either write out a structure that says 23 plus blank equals 41, or again, some students might be able to recognize that you can just subtract them to get it, and they'll write that as a structure, and that's acceptable as well. And then, of course, we have a number bond also to represent it. For the total unknown and the add unknown, it's pretty straightforward, and there's only one answer. Let me repeat that. For the total and add unknown, there's only one answer. When we're looking at both add-ins unknown, there is a list of answers, not just one answer, a list of answers. This is the kind of word problem that students shy away from. When you see an open-ended question on one of the standardized tests that looks like this, we want the students to have already seen this in math class before they take that achievement test. This question is very open and broad. It says, Rachel has 7 CDs and 2 boxes to put them in. So how many CDs can she put in the boxes? You might look at this question at a first glance and think, oh, well, they want one case. Okay, how about if she puts 5 in one of them and 2 in the other one? And then it sounds like you finished and answered the problem. The answer is every possible case of how many she could put in every single box. And we need our students to explore and exhaust every last case of what it would be like to separate 7 CDs into 2 boxes. There will be an open-ended question essay associated with this particular part for your exam a week from today, where you'll be asked a question about both items unknown, and you'll be asked to come up with this kind of a list as your solution. I have seen a lot of students have a block with answering this question correctly because they feel it's unfair, because they feel that it's too challenging, because they feel they'll never need to know it, because they feel annoyed by it. It's hard to get past all that psychology with the kids, but we have to push through and get them ready, because when they take their GEPA and when they take their New Jersey Ask and all the other things, there will be questions just like this on there, and we need them to be ready to answer them and get credit for them. So here's what the answer is to this question. It's a list of 8 equations. You can write this out as 8 sentences. Rachel can put 7 in the first box and none in the second box. She can put 6 in the first box and 1 in the next box. She could put 5 in the blah, 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 and carry on. Or you could just say she can put them in the boxes in this way and then list all these equations. Guys, please focus with me today on both add-ins unknown. It shouldn't be that hard, and we're adults, we're not children, so it's easier for us to see how to do it. The kids are going to find it tiring, and they're going to resist it. This is one of your challenges as a teacher, is to bring that education to them even when they feel like they don't need it. And it's hard to do because this feels like it's something that's not practical or that's a little bit outside the box. The truth is, yes, it is outside the box, but it is on that test. So we got to make sure that the kids understand it. All right? So when it comes to both add-ins unknown, there is no strip diagram. There is no structure with a missing box. There is a list of equations as your answer. And that's really crucial, and I need you to remember that, because as we carry on and try to classify and explore all these different kinds of word problems, the kids need to know about takeaway problems and about add to problems and about take apart problems and all of these other things, but they also do need to understand how to do both add-ins unknown, which is to come up with a list of equations as your answer. And our last style of word problems is called compare problems. Compare problems involve the comparison of 2 quantities. There is a larger quantity, a smaller quantity, and a difference between the 2 quantities. Compare problems have 3 subtypes as, again, difference unknown, bigger unknown, and smaller unknown. So let's see if we can come up with a basic structure associating these. We would have the bigger minus the smaller is going to equal the difference. Okay, let's take a look at this structure. This is a basic subtraction structure for compare problems. In this case, as a reminder, right here, you're looking at the minuend. Right here, right, you're looking at the subtrahend. And right here, you're looking at the difference. Okay. So let's review. A basic subtraction structure is a minuend minus a subtrahend is a difference. In the case of compare problems, the first number is the bigger quantity, the next number is the smaller quantity, and the last number is the difference. Compare problems are related to subtraction in the same way that put together take apart problems are related to addition. But as you can see, once again, this is all just the same thing anyway. Addition and subtraction, surprise, are the same thing anyway. So let's look at what some examples of compare problems would be so that we can have a good grasp on what to expect when it comes to compare problems. In the first case, we have the difference is unknown, meaning the last thing is unknown here. And we have Rachel has 41 CDs and Benny has 23 CDs. So there's 2 kinds here. How many more? How many more CDs does Rachel have than Benny? Or you could say, how many fewer CDs does Benny have than Rachel? Okay, and if you look closely, you'll see that we have some strip diagrams, and now we've included this lovely oval here to represent the subtraction piece for the subtrahend. or the difference rather, excuse me, the difference. What we're doing here is we're looking at this as if it's the bigger number or the minuend. We're looking at this right here as if it is the subtrahend, and we're looking at this as if it's the difference. And the reason why is because in this case, the difference is unknown. Let's also mention for a minute that we are not letting time go by here like we were in the first scenarios. And we are also not doing one person with a certain amount of things and adding to that. Instead, what we're doing is we're comparing two things, two people with CDs. It could be the heights of two mountains. It could be, you know, how many milliliters of salt solution are in the test tube. It's about quantities, but being compared with a difference and having two different quantities. That's how you can tell that you're looking at a compare problem, is that we've used two different quantities from two different people or two different things. So here's what the strip diagram looks like for this scenario, and here's what the structure looks like. And we're expecting that if you're reading something like Rachel has this many, Benny has this many, and then there's a question like this, you're able to come up with this kind of a strip diagram. And notice the strip diagram is showing a little bit of an oval to represent what the thing is that you're looking for, okay? Then we have the bigger unknown. So we start by saying, now Benny has 23 CDs, Rachel has 18 more than Benny, so how many does Rachel have? Okay, well, if how many does Rachel have, and Rachel is the one with the most, Rachel is going to be the strip diagram that's on top, the largest strip diagram, and Benny is going to have the smaller one, and it's 23. We also have a nice structure here to use. 23 plus 18 equals what? Down here, we have another scenario. We could start by saying Benny has 23 CDs, and Benny has 18 fewer CDs than Rachel. How many CDs? So if you look at these, this is more, and this is fewer. That also happened here. In both of these, we just kind of like switch the words around a little bit more. Rachel has, how many more does Rachel have than Benny? How many fewer does Benny have than Rachel? The same thing happened here. How many CDs does Rachel have? And then we have how many, we have Benny has 18 fewer, and here we have Rachel has 18 more, is what I mean. So, you know, this is what we mean by the compare. It's two people. And when it's two people, you have to start with knowing what the subtrahend is here. And we're trying to find out what the minuend is because we already have the difference, okay? Here are the structures. And then for the smaller unknown, it's not that different. Rachel has 41 CDs, and now Benny has 18 fewer than Rachel, so how many CDs does Benny have? Now, if you look here, you'll see sometimes it could be a little bit confusing which one is bigger and which one is smaller, but we do want it to be that we at least recognize that difference is when the empty box is in the oval. And smaller unknown is when the empty box is in the strip diagram. Students can use that as a guide, and I hope that when you're doing your questions in WebAssign and your practice, that you'll come back to this video and that you'll come back to this PowerPoint to consult these ideas again and look at them, okay? I hope that makes sense, and I hope that that's clear. What I'd like to share with you now is the activity that I'm going to ask you to work on. What you're looking at is the activity that I described earlier that I had students in the past create. And we made a little bit of a key so that we could have an easy way to code these things. And it may help you to print this paper out and to look at it. Or if you want, maybe you could just take a notebook and you know, take some notes and write down what you think your answers are. You know, any way you feel like you'd like to do it, as long as you're, you know, kind of going through them and trying to work through the questions. We have nice little abbreviations to represent the different styles. Notice I've grouped them according to the style, and then within each group, there's the three subtypes here, the different subtypes. And what you're going to do is basically read this question and see which one it fills into. Let's try one together. Kesha had 20 sandwiches. She gave away 15. So how many does she have now? So if she started with that and she gave away something, that means that we have the result unknown, right? This is a result unknown. And also notice that time has gone by. She had a certain amount, and then she gave some of them away. So this is a take from problem, and we're going to say that it is a result unknown. So I'm going to say it's TR. Now let's go and see what the answers are at the bottom. And the answer to number one, as you can see, is TR. So based on our lesson and based on our knowledge of these different kinds of questions, we're able to go and read number 2 and make a hypothesis about what we think the answer is, and then go and check to see if we're right. I'm going to ask you to actively use this tool to prepare for your exam. There will be questions that look very much like these questions on your exam, where you will be asked to determine which style and which subtype of question you're looking at. You have a week, you have from now until next Thursday to get comfortable with that, and we're going to work on this activity today in class. When we get together next week, we will have I will show you what your essays are, and we'll be able to do essays together in class. We'll work on this, and we'll also work on the scientific notation worksheet as needed. And it'll be a general question and answer session where everyone is reviewing and preparing for the exam. So my friends, you can expect that our next class will be just exam prep, including reviewing this worksheet and the other materials and all the WebAssign homework. A week from today will be your exam. Okay? So I hope that makes sense. I hope that that's clear. And what we're going to do now is it is 8:43, and we are going to take a break shortly. But before we take a break, we're going to stop our share, and I'm going to come back and hang out with my class and my students here and say, I hope you appreciated my lesson. I tried to make it as clear as I could for you. If you read chapter 3.1 and 3.2 beforehand, it probably was a lot more clear for you. If you felt like you didn't really understand it, which a lot of people have trouble grasping this the first time, I strongly advise you to open your textbook and read the chapter. In the chapter, it explains it very well. And then you can always come back to this video and watch it again. So before we, I'm going to stop our recording, and then after our recording, I'll hold questions if anyone has it. Thank you so much, my friends, for your attention to this lesson.